So what is Boyle's law? Boyle's law is nothing but volume of a given gas of a which is inversely proportional to the pressure. Okay, so P is inversely proportional to pressure at keeping temperature constant. So if it is inversely proportional, then we can say P is equal to constant into volume. Sorry, constant divides volume. So if you bring this volume here, P times volume is equal to constant. This is the formula. So PV is equal to constant here. Suppose if we are considering two types of gases, otherwise if one type of gas having volume 1 and volume 2, okay, and then pressure also varies, P1 and P2, then you can come to know P1 V1 is equal to one constant, and then P2 V2 is equal to the same constant at constant temperature. If you are keeping a gas of different volumes at different pressure, keeping temperature constant, same temperature, okay, then that constant will be, this is the proportionality constant. Proportionality constant. This temperature constant takes place as same temperature. Same temperature is maintained for the first volume and pressure. The same temperature is maintained for the second volume and pressure. If it is so, then that is equal to some constant case that is same. Suppose it can be applied for n number of gases. If you consider P1, V1, P2, V2, P3, V3, etc. until Pn, Vn, the same constant is applied. So this is for a dry gas. This Boyle's law, the graphical representation shows it is inversely proportional. You are taking V along, volume along the y-axis and 1 by P along the x-axis. This is two important parameters. If you take P, normally a pressure, definitely it will not be a straight line, since it is inversely proportional, right? So, suppose if you want to get this plot, you have to take 1 by P in the x-axis and V in the y-axis. What it is here, PV is equal to constant. Otherwise, P is equal to constant into 1 by V. Okay. So if the constant is 1, if the constant is taken as 1, then we can say directly P is equal to 1 by V. Whatever pressure, that is 1 by V. Otherwise, whatever volume, that is 1 by V. So if the volume is 1, then the pressure is 1 by V. If the volume is 2, then the pressure is 1 by 2. Like the way it is continuing. So we can say this law can be verified by plotting a graph of V versus 1 by P like this. Then V versus P like this. As I've told you, no, this will not be a straight line. So, okay. So P and V, if you directly combined, then always come to know P is inversely proportional to V. So if you take volume in the y-axis and pressure alone in the x-axis, then you'll be getting this hyperbolic curve. So for example, this is a hyperbolic curve. Here temperature is constant. Always isotherm. Okay, that means constant temperature, same temperature is maintained. Okay, then PV versus P. We are taking like that. PV versus P. The product of PV and P. If you keep PV in the y-axis and the P in the x-axis, then it is same pressure. So pressure and volume is the product. This product is constant we talk about, right? How we can say constant? For each and every pressure points, the product will be constant. Okay, this is the meaning. So either it is first volume or first pressure or second volume or third volume or third pressure, etc. N volume or N pressure, it will be the same constant. Okay. So this graph shows like that. Okay. It's very important. This can be explained in molecular motion also. The kinetic energy possessed by the particle is the major strike over here. Okay. The kinetic energy is responsible for the pressure. That means all the molecules are started moving. If the volume of a gas is reduced to its half of a original volume, the same number of molecules will be there. but it will occupy the half space. The space is now reduced. So the number of molecules striking at unit area of the walls of the container at a given time will be doubled. Okay, so how we can say it is doubled? So now the space, okay, the space for each and every, let the space for each and every molecule be 1. Okay, now if you reduce the space into half, okay, then the volume can be, now it will be double because the space is reduced, but the number of molecules are same here, same number of molecules. So what is the meaning here? The number of molecules striking at unit area of the walls of the container at a given time will get double. That means in one, there are number of molecules. In half, there will be 2 number of molecules. We can conclude like that. Okay. So keep in your mind this point. This is very important. So the number of molecules striking at unit area of the walls of the container at a given time period will get doubled. Okay. But the volume is half of its original volume. So that the pressure also doubled when compared to the initial one. So if the volume of a given mass is doubled, for example, if you are increasing the volume, then the same number of molecule is going to occupy this volume also. Okay, the molecule, the same number of molecules will have double the space to move about. So consequently, the number of molecules striking at unit area of the walls of the container at a given time will become 1/2 of the original volume. So if you consider one space, you will find half a molecule only. Okay, that's the case. This is the theoretical concept. So converse theory and the original theory you must keep in your mind. Okay, in consequently, what is the result for the converse? If the volume of a given gas is doubled at constant temperature, the same number of molecules will have double the space to move about. What's the point? So now, so this point you should keep in your mind. So the pressure also will be reduced to half, okay, of its original pressure. So this theoretical point of view, you should keep in your mind. You'll be definitely asked questions from this. Then, hence it is seen that the pressure decreases, okay, will be reduced to half of its original pressure. Hence, it is seen that if pressure increases, if you increase the pressure, this is the third case. First case, you'll be seen like this. What is the first case? Do write along with me. So what is the first case? We are going to write. Once here I'll write. This is the first case. In the first case, you will given volume is half of its original volume. Okay, so half of its original volume. Okay, then in what about the number of molecules? Number of molecules will be doubled 2 times. Okay. Then what about the pressure? Pressure automatically doubles. This is first case. What is the second case? In the second case, we are going to increase the volume. So that is, the volume is getting doubled, so that the number of molecules will be reduced to half, so that it can occupy the extra space, right? So in one space, only half a molecule is there. That is the meaning, that occupancy they are telling. Now in one space, 1 molecule. In 2 space, half a molecule only. So 2 space are allotted for 1 molecule. So we can conclude half time. Okay. So half a molecule we can say. That means it is the number of molecules reduced to half. Okay. So the pressure also reduced. Reduced to half. Okay. This is second case. What about the third case? The third case will be, you are increasing the pressure. The pressure is increasing here. The pressure is increasing. the pressure is increasing. Okay. So what about the volume? The volume of a given mass of gas decreases at constant temperature. So if you increase the pressure, definitely by means of this, by the activity of the number of molecules, by looking at the kinetic energy of the molecule, the volume automatically decreases. Okay. So this is generalized in Boyle's law. What is Boyle's law? Pressure and volume is inversely proportional. Okay. So by observing all these cases, Boyle concluded this. What is the significance, Max? Major significance. Okay, this is the significance. Pressure increases, volume decreases at constant temperature. That is needed to be taken care of. Otherwise, the temperature may affect. Okay. So atmospheric pressure is low at high altitudes. So air is less dense. Hence, a lesser quantity of oxygen is available for breathing. This is the reason why mountaineers have to carry oxygen cylinders with them. Okay. When air is blown into a balloon, volume and pressure inside the balloon increases. Is it clear for you? Okay. So what happens? The Boyle's law is not violated as the law is valid for a definite mass, whereas mass increases when more air is blown into the balloon. So this is how the balloon will not violate Boyle's law. We can think out, right? In a balloon, we are producing air, we are blowing air, right? So the air is automatically increasing. That means the mass of the particular balloon is increasing when it's blown. That means volume. If the volume increases, mass also increases in that. But we are not talking about that case. Okay. The masses, the number of molecules quite a bit constant over there. We're keeping that. We're not increasing the number of molecules. Okay. So balloon is not violating. This point also will be asked. This is very important in this note point. Okay. Then examples are given. You have to compare P1 V1 is equal to P2 V2 by means of the Boyle's law. Suppose this is the 4 parameters, right? There are 2 different pressures, 2 different volumes. Out of it, suppose you'll be asked any one of the parameter. Okay. This is one famous problem. You can easily done with this. What is the second problem? A gas occupies 600 centimeter cube under a pressure of 700 millimeters of mercury. For find under what pressure the volume of the gas will be reduced by 20% of its original volume. So you'll not be given volume the direct, the second volume as the direct one. You'll be given 20% of the original volume. So original volume is taken as 600. That is the original volume. 20% has to be reduced, means you should find first 20% of the original volume. That is 120 centimeter cube. You should reduce that 600 minus 120. That will be the new volume. That is volume 2. Okay. 480 centimeter cube. Now you conclude all these parameters and then is asked. P2 is asked now. So using the Boyle's law, you can easily find all these things. Okay. So similarly, from the given one, you should carefully examine all the problems. See here, 2 cylinders, both containing carbon dioxide, are connected together by a tube fitted with the tap. The capacity of one cylinder is 4 decimeter cube and that of the other is 1 decimeter cube. So capacity is given. That means volume. Okay. The pressure in the first cylinder and the second one is given. What will be the final pressure in either cylinders on opening the tap if the temperature remains constant? You are keeping the temperature constant. What they're asking, the total volume of a carbon dioxide will be 4 plus 1. That is the total volume. Okay. For the first cylinder, it will be P1 V1 is equal to P2 V2. You can calculate the pressure 2 of the first cylinder. Sorry. Yeah. 2 cylinders have taken, both containing carbon dioxide connected by a tube fitted with a tap. Okay. The capacity of one cylinder and the other. Okay. The pressure in the first cylinder is, and the second is given. What will be the final pressure in either cylinders on opening the tap? Okay. Okay. If the temperature remains constant. For the first cylinder, you can take like this. P1 is 560 millimeter of mercury and the volume 1 and volume 2 will be taken as 1 decimeter cube, but as a total we are considering as 5 volume. It is for the carbon dioxide. The total volume will be 5. So what is the pressure to according to the 5 decimeter cube? So that is 448 millimeter of mercury. For the second cylinder, it should be like this. For the second cylinder, we are considering 1 out of total, that is first cylinder out of total, that is volume 2. First cylinder volume is 4 decimeter cube out of total. Second cylinder volume is 1 decimeter cube out of total 5. So like a way we found P2. What will be the final pressure? This is the final pressure. Okay. So on opening the tap, the pressure will be like this. Okay. We are considering the first one and the second. The volume of a given mass of a gas will go to this example 4. Okay, volume of a given gas of a given mass of a gas of some pieces of marble in a container at 760 millimeter of mercury in 100 ml. If the pressure is changed to 1000 millimeter of mercury, the new volume is 8 milliliter. Find the volume occupied. So here we have to find the volume. Here also pressure remains constant. So let the volume be VML. At 760 millimeter of mercury out of total 100 volume, V volume is removed, right? Then at 1000 millimeter of mercury out of 80, this V volume will be reduced. Because you know that the volume is decreasing when the pressure increases. Okay. So by Boyle's law, you can do this. P1 is taken as 760 and V1 is 100 minus V. P2 is taken as 1000 millimeter of mercury and V2 as 80 minus V milliliter. Then out of it, you can find the required volume. So that is 16.6 milliliter. It is coming. You know that, right? So you can bring this number here, this one, then this one. Bring V to the right side, left side, and numbers along to the right side, and do calculate with this. So the volume will be 16.6 milliliter. So try all these numericals. Okay, and then you have to do all the numericals. Okay, suppose, yeah, you have to use all the formula. So what are all the examples given? You can follow this example and do the exercise problem. There is a relationship between temperature and volume. So this is Charles' law. Charles only concluded this law. What is Charles' law actually? Charles's law, the volume of a given mass of a dry gas, keeping pressure constant, it increases or decreases by 1 by 273 of its volume or 0 degrees Celsius of each 1 degree rise or a decrease in temperature respectively. So what is the meaning? Volume and pressure is directly proportional. Sorry, volume and temperature is directly proportional. Volume is directly proportional to temperature. They are keeping this thing. So increase in temperature at constant pressure causes an increase in volume. Decrease in temperature at constant pressure causes decrease in volume. That means V is directly proportional to temperature. Okay. This is because the air inside the balloon expands with rise in temperature. Why the balloon burst? Okay. So this is the reason. If the volume increases, then the temperature also increases. Okay. Then suppose in 1802, okay, so Gay Lussac, he performed this experiment along with Jacques Charles. So he followed his experiment. So fixed mass of any gas, you are considering a fixed mass of any gas expands or contracts respectively by 1 over 273 of its volume at 0 degrees Celsius. Okay, this 273, it comes from the Kelvin. You know that the absolute temperature, 0 degrees Celsius is equivalent to 273 Kelvin. So 1 over 273 Kelvin is given to this. And then each degree Celsius rise or fall in temperature, rise or fall. Okay, each degree Celsius of rise or fall in temperature provided the pressure remains constant. Okay, so the gas may expand at a degree Celsius rise. The gas may contract at degree Celsius fall. Okay. Yeah. So then what is the mathematical expressions for Charles law? Now we can conclude this. This is the volume. Okay. So we are taking volume at 0 degrees Celsius. So this is the volume at some temperature. This is 0 degrees Celsius. This we know this is the volume at 0 degrees Celsius over 273 into time taken. Okay. This has to be added, each and every volume. How it is calculated? How it is the increase in volume? We are talking about the increase or decrease in volume, right? The gas may expand or uh, it may uh, it may expand or contracts, right? Due to the volume at 0 degrees Celsius. Okay. So what is the volume at 0 degrees Celsius? 1 over 273 of its volume at 0 degrees Celsius. What is the volume at 0 degrees Celsius? This V naught. It is the volume at 0 degrees Celsius. Okay. So 1 over 273 of its volume at 0 degrees Celsius. So 1 over 273 of V naught. Okay. For each degree Celsius. So it has to be added with respect to time also. So V naught by 273 into time plus V naught will be the new volume. That volume may be expanding or contracting. Okay. So here V naught is taken outside common. So it will be 1 plus T by 273. So if you take LCM, then 273 plus T by 273. So V is equal to V naught by 273 into time taken, because we are taking like that. V naught into 273 plus T. And then this denominator can be taken like this. This is V. This whole 273 plus small t will be taken as capital T. So this comes. Okay, for a given mass of gas, this V naught by 273 is a constant for given mass. Okay, so that constant is taken as K. So K into T. So V is directly proportional to temperature. From this experimental result, he has calculated all these things, because temperature means we have to stick on to the temperature. We have to keep the absolute temperature, that is the V naught. Okay, that is the absolute temperature. So V by T is equal to K. This is the formula. With this formula, you can apply it for any n number of gases, 1, 2, 3, 4, 5, 6, etc. until n number of gases. So this is the formula at constant pressure. This is the Charles law. V1 by T1 as P1, V1 is equal to P2, V2 is equal to constant. Here we are taking about V1 by T1 is equal to V2 by T1 is equal to constant. Okay. So based on that, we are given some graph also, volume and temperature. Okay, directly you'll be getting the graph. So keep in your mind. So what is the explanation given based on the molecular motion also you should learn it next to that Boyle's law. It resembles the Boyle's law. You just have a look of this. Keep going on about the significance, all the problems, everything. Okay. This is very important. Go through all the problems and then do all the exercise also. Then we'll see the gas equation later in the next class. So go through Boyle's law and Charles law right now. Thank you.